Hello everyone, welcome back to KillerRabbit Codes. We'll be continuing building our virtual machine, and I've set up the start of a project, but to cover some of what I didn't upload last week because things got very busy for me. But I managed to earlier build out and finish most of the linker, if I could find it. And so what we do is we basically statically link everything, and all of it's boring and just going through every bytecode function. And there's a ton of to-dos because we don't really care, because we want to build the interpreter and hopefully run it today. And so yeah, so we're going to build the interpreter. So to start, we'll create a struct called a VM, and the VM will need some things for it. I'm going to call it stack. VM stack. Alright, so for a stack, it's actually going to be a very interesting structure. Is going to have an operands stack. And the way this is going to work is, this is where things get interesting, is we'll have what's called a pool. It's a vector of U64, and we'll have a stack as a vec of U64 as well. And so the way this is going to work is, because of algebraic effects, since we could unwind the stack and start a thread of execution, well, not quite a thread of execution, basically we could go, because of the way algebraic effects work, we can go down the stack and start executing code that sort of branches off the main thread, and then we come back and then continue where we left off. So to support that, the way this is designed is whatever current, because what could happen, like the reason why, I'll explain. Basically the issue is, because if we split off, another effect handler can be fired off, and we go back and chain off of that, things will get complicated. And rather than having like multiple stacks sort of just floating around, or like popping everything off and on and then pulling it out, I think that'll get messy. We're gonna have a spaghetti stack, and so each successive in the stack, each vec is like a separate sort of, I guess, thread, and then we just merge that onto each one back until we get to the very end. And so, and the pool is just that whenever we pop one of these off, we just put it in the pool to keep it around, so then if we need to do it again, we already have a vec allocated and ready to go. So let me think about some more things. No, I think it's good. Okay. So we need a constructor. So pool should arguably just be empty, and the stack should probably have some amount of space pre-allocated, because each successive, actually, though, it's a stack, it's a spaghetti stack. This could actually be, I don't know, what it should be is a vec vec with capacity. This should be something fairly large. So let's see. What would be a good number? Because each value would just be a U64. So, what would be a good starting point? Like that's 1,000 slots. Say times like 10. Let's do 100. I think that's fine. And so some operations are let's see, what do we want to do is add execution. You know, here's an idea. Let's just, for now, make the assumption that we will not be branching off, and we can add that when we do effects. So, for this, we should have a push which simply just does a self stack dot last mute actually, here's an idea. Let's create a helper trait. So we pub trait into U64. Which has the convert. Actually, let's change that. The capitalization is slightly better. Take a self and we become a U64. Now we impl into U64 for U8. Let's just do it for all these types. So this would just be a from LE bytes that is not enough. That I think is there. That should be enough. to U16, I16. It's too much. That would be bytes. This is wrong. That's big Indian. Bytes. 0. 1. And then it's basically going to be probably about the same. U32. So this will then be a bytes 2 bytes at a 3. Then for U64, just return the self, and then for an I64, do simple bytes at 4. Actually, do we have to do that? We can just do a bytes. Value can just be a T. No, I haven't. I'll name these. I'll do it into U64. I need to I call it convert stack value, and we'll have convert get replaced with into, and then I want to add another method, which is convert do from, and technically I can use the to and from traits in Rust, but I'm like maybe to self. From be bytes equals value dot in as 2 LE bytes. There's 2 bytes at 0. So it's basically the same as this. That's alright. Alright, so now I need to do a 8 LE bytes This from is going to be kind of boring, but let's make this one first. Because we're just going to return value. And then we'll do pop t for its stack value. It's in map from and what is going on here? Stack value from, and then just pass it X, and there we go. Now we got the cooperate. All right. So now we have that. Let's see. So now we have the stack. Now we can go back to VM. We're gonna add a thing called a task, and basically because I think that threading is a great thing, but for the language I want to design, I feel like threads are too low level of a concept, and so we're gonna support async, essentially, in our language. So, and to facilitate that, VM will contain a task. And a task is basically everything that is used. Also, I just realized we need to do one last thing in, so let me just create task.rs, create that. But I forgot one thing that we needed to add or make. It's called the local stack, which basically holds all of our local variables. And arguably, it's kind of the same as an operand stack. And that it's a little more complicated. Because every function can have up to 256 variables. Which means we have to constantly shift things around. So what we're going to do is we need a constructor. I'm going to call it stack. Let's call it locals. Since this could actually be bigger, this could probably easily take up more space. I'm just gonna use the same value, just for now. So we want to load. Oh wait, need a index. And then we need one last thing, which is the offset, which is basically where in the locals are we? So no do is do self locals last mute map. So locals, and so equals index as usize. What I want to do is while locals the lane is less than offset index. We want to do locals dot push. Let's just do 0. I think it's fine. So we'll just load that up, and then we'll do locals at offset plus index equals value dot into. Store is going to be kind of. Oh wait, I got this backwards. This is store. Load, we return the value. This is where things get a little sketchy, because we should always have a slot for it. Because we have 0, but you'll get weird results if otherwise. This is why eventually we'll add verification of our bytecode, and this should not become an issue. So what we'll do is we'll do what do you call it? A convert stack map from locals, and then we'll do that expect, and it'll be we should always have locals available. There we go. And so we'll use the pool later. So a task has a stack. There's the operand stack, and then the locals is the local stack. And what else will we need? Oh yeah, we need a custom struct. We need frames, so stack frames, and we'll use the same pattern as before, where we have a pool vec of a frame and a stack, which is a vec of frames. And so this way we can either actually no, we don't need a pool. Most of the frames allocate stuff, which they very much should not. And so we'll just put the definition of a frame here. And so for a frame, we have the stack bottom, the size. We have a equals bottom, which is basically, this is into the operand stack and the local stack, and it tells us where we are in the frame or in the stacks, so then we can just manipulate them. So a task contains frames, which honestly we should probably just not make it public. And then let's see. Oh yeah, I know we need not there, but we need a program counter so we know where we are in the byte code. And this will just get continually updated as we execute. And so I think this might be good enough for now. Oh, I know what we're missing. We need code, which would be a static like you actually. Oh, look at let's open up this. This is internals, tables, functions. So, this is what we want. Yeah, okay, so this will just be a static U8 slice. I want function information, which is a static function, which should be somewhere. That. So then we can access these fields and figure out things in the frame. So make some helper. Do we want to pre-allocate a few frames? Let's this is variable, so you never know exactly what that could be. So we need basically we're going to construct that. Bottom. Yeah, let's make it like this. Size, program count. Actually, that you don't need to provide that. Actually, we need to provide the function. Actually, didn't have to provide that. We just provide a function index and the function index, and then that should return a self. So I should theoretically be able to do a functions let function equal functions. That's not what I want. No, it's function table. You want the index with the function index, and now we get a function, and we do let code equal bytecode table index function dot bytecode. And now we could do stack bottoms, locals bottom, code, and function. Oh yeah, and then get that room counter can now be 0. I guess we should probably add I think it doesn't have to be pub because it's local. I'm gonna make it so you have to provide a frame for push. And then pop is going to be, will give you back the frame. Alright, so with that in mind, now we can do start implementing task. Locals and frames. And there, create a task. Actually, a frame I think has to be slightly more public. Actually, no, it doesn't have to be, because we could just do then call function. We should take a function index. And so what this will do is, actually we need to add a few more things this. Basically we need a way of getting the, what do we call it? Basically we always need a way of knowing where we have to put those indices on. So we do that. Stack.len. And we'll do locals bottom dot locals dot len, and then we could do a self dot frames dot push frame new stack bottom function index, and then we let that do its thing, and now we can do the main logic function. It is interpret, which this will just be a single step. It consumes one bytecode and code point and executes it. Right now it will not blow up, but we'll just call this in a loop. It should be fast. So what helpers do we need? So we need to get the current frames I have an idea. So we'll add a function which would be let's call it decode instruction. And what I'll do is I'll just index into the code point and give us the U8 there. Not code at the self.program counter. Then we'll have increment counter amount this needs to be a mute. Program counter, we'll take in the amount. I'll have a decrement. We'll do that. And then just for the heck of it, we'll return static U8. This will be a self dot code at self dot program counter until the end. And that should be all that we need the frame to manipulate. And over here I'll pull up this, because I don't remember exact opcodes. Everything, which I actually now thinking about, will be in the linker. Linker. Which, I'm like, now thinking about it, go back to bytecode. I'll just look in here. These are now irrelevant because I was going to use this for validation, but it'd be a nightmare to change these code points. I don't really want to do that. So I'm going to change it. I don't need this information anymore, so, and plus it makes the implementing this so much simpler. So I don't need to keep track of that. But interpret, the way it's going to work is going to let let's see. We need to get instruction be self dot frames dot last. Let's do a map. Frame dot code. We should have a frame. Oh, I know why. Because that doesn't have. Wait, doesn't. Oh, wait, a stack frame has to be a spaghetti stack as well. Dang it. No. Thought it would be nice and easy. And then we pull this. All right. No, but I need to now do. Yeah. Flatten. frames. Oh. All right, so this I do decode instruction, match instruction, and on 0 this will be a push constant. And so what we'll do is simply just go ahead and get the, I should probably just get the frame. So once we get the instruction, on 0 we use a frame, decode the instruction, then we do let code equal frame dot many bytes, and then we construct a U64. From LE bytes, and take code, and we start from 1 because that's the instruction, and then we go 9. Does this work? No, it won't work. Of course it won't work. There. So now I just need to place these each with the right indices. So we have a value. And so now we can do stack dot push the value. And then now we're going to do the next, which is going to be pop. This needs to be corrected, and all these numbers need to be fixed. I start. No. No, wait. I want to fix. I can't fix it now because but the code points are basically the same. Fine. I'll keep them. It might be redundant, but I'll keep them. There we go. Now I just need to do 6, which is pop. Just pretty straightforward. Probably gonna yell about types. I make you do just U64. That's fine. Alright, so now 7 is, we should write this down. Pop dupe, which basically we just take whatever the heck is on the stack and put 2 of them on there. Stack.pop. Tell you this should also not be possible with verification, but so it doesn't matter. We expected this because this should never happen once we add the verifier. Now it's expecting a type, which we'll just provide U64. And now stack push basic value, and we do it twice. And we don't mess with the reference count. It's important because the compiler should emit the reference counting instructions so that Perseus can do its thing. Plus this will do nightmare on reference counting, because it'll be like, alright, it just makes more sense, like, alright, if you do a dupe, increment the reference count, then do the dupe. And then swap is a fun one. Which is basically this, but I would do value 1, value 2, and put value 1 in there and value 2 in there. Just flip the top 2. 9. Is load local. So we need to fetch this. Code at 1. And so now we need to do self-thought local. Whoa. Oh, self-thought. Oh, we need to yoink this. Locals dot load. Actually, this is store. Oh. So offset would be frame dot locals bottom index and then value. But this is store. Oh, I forgot some very important things. Is I need a last mute. And so this will so then I need the frame again. Self dot frames dot last mute. Why are we doing that? And then frame dot increment counter. This will be 9 bytes. And then here should be 2 bytes. Same here. But we'll get rid of. This is actually going to be load. Value. That. And we're just gonna treat it as a U64. Self.stack.push value. And then the next instructions, which are 11, 12, 13, are related to up values. So create, load, store up values. And we will not be handling those today. And then, not 14. Oh, did I screw? Wait, hold on a second. So, we have load, store, create, load, store. Hold on. It's not 9, 10, 11, 12, 13. Okay, that's fine. Okay, I thought I screwed up the math. No, I've got the arrow. And then same with 14 through 15 is we need load, store global. And then we need to do floating point operations, or just the numerical operations, which I realize this video has been running on for quite a while. I guess I will not be doing an interpreter today, but this is just part of the interpreter. So I'll see you guys next time. Goodbye.